Hey guys, Mr. Milton here. Today we're going to look at linear inequalities notes. At the end of this video, you should be able to show all solutions to a linear inequality by graphing. You should be able to explain what a solution to an inequality looks like. All right, remember from Unit 2, if we had x is greater than 4, when we did this on a number line, we made sure we had 4. We used an open circle to indicate that this was a barrier, but it was not included in our solution. And then we shade it to all the points that would be a solution to the inequality. An inequality has infinitely many solutions, a bunch, not just one, which is why we need to graph them to show the solutions. Okay, so that's all from Unit 2, things that we're going to kind of use in this lesson. Okay, in the inequality above, how many variables does the inequality have? It just had one. That was x. What did the solution look like? It was like x is greater than 4. Anything that's above there. Okay, today we'll be working with inequalities involving two variables, which means the solution will look like an ordered pair. Ordered pair. Right? Because in our solution before, we had x is greater than 4. There was any number that was greater than 4, so we could say 5. We could say 1,824. Okay, these are all different solutions. Because our solution is going to have an ordered pair, any point that makes it work is going to be a solution. Okay, so here's what we have. We have y is greater than or equal to 1/2 x plus 3. What we're going to do is graph this line and just kind of forget about this for right now. Let's just graph this line. Our y-intercept is 3. Our slope is 1/2 up 1/2. We do that here. Down 1/2, down 1/2. Okay. And now, I'll bring your attention to our line. All right. So, it says y is greater than 1/2 x plus 3. We are going to look at this sign, and it's going to tell us a couple of things, kind of like what it did when we were writing our inequalities in Unit 2. If we have a line under it, we are going to have a solid line. If we don't have a line under it, the line will be dotted. Okay. If our y, if it's less than, y is less than, we will shade below. And if it's greater than, we will shade above the line. Okay, so here we have y is greater than or equal to. So or equal to means we have a solid line as we draw. And greater than means we shade above. So everything above this line is a part of the solution. Okay. Now it says determine if the given point is a solution to inequality. A couple ways we can do this. We can plug it into the equation. 0 is greater than or equal to 0 plus 3. 0 is greater than 3? No. Okay, 0, 0. We could also place it on the graph. Where's 0, 0? It's right here. Is it where the line was shaded? No, it's not a solution. Okay, -2, 7. -2, 1, 2, 3, 4, 5, 6, 7. It's right here. Is it a solution? Yeah, it's where it's shaded. We could also place it into the equation, right? 7 greater than or equal to 1/2 times -2 plus 3. And if we did that, we get -1 plus 3. 2. So is 7 greater than or equal to 2? Yes, either way. And then 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. Boom, 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 right here. It's on our solid line, so we know that it's a solution. Okay, but also if we plug it into our equation, 5 greater than or equal to 1/2. 4 plus 3, 2 plus 3, 5 is greater than or equal to 5. Yep, that's true. Okay, so we see that plugging in our values or looking at a graph is ways for us to see if a point is a solution to the inequality. Notice that the process is almost exactly like graphing lines except two things. You must make your line either solid or dotted. Okay, and the line separates the solutions from the non-solutions. And then you must shade on one side of your line. The shaded region represents all the solutions. To determine which side to shade, you must have your equality in slope-intercept form. That's one way to do this. If the sign is greater than, right, whether it's this way or this way, then you shade above. If the sign is less than, then you shade below. Okay? And so here we have y is greater than negative 2/3 x plus 7. This is in slope-intercept form. So we go to our y-intercept, 1, 2, 3, 4, 5, 6, 7. Our slope is negative 2/3. I go down 2 over 3, down 2 over 3. Okay, with my line here, it is, all right, with my inequality sign, it is just greater than. And so I am going to use a dotted line. Okay, just indicating that I know that my line is not a part of the solution. Okay, and so I have that, and then I'm going to shade above because it's greater than. Okay, so here are where my solutions are. Okay, it says give just one solution to this inequality, and that's any point that's over here. So I'm going to choose this point. I don't know what it is. See what it is. It looks like it's 6, 6. Okay. 6, 6 is the solution. Okay, I do not want to choose a point that's on this line because it's dotted. Okay, here I have my y-intercept is -1. My slope is 5, so up 1, 2, 3, 4, 5 over 1. Down 1, 2, 3, 4, 5 over 1. Okay, this is or equal to, so my line should be solid. So I should have a solid line there. All right, and then from there, I'm going to shade below because it's less than. Okay, so below my line, all that shaded is part of my solutions. It says give just one solution. Okay, and so I'm going to choose this one at 2, 0. But anywhere where our shade is should be a solution. All right, number 3, it says 4x plus 3y is greater than or equal to 9. What do you have to do first for these? We want to change to slope-intercept form. Okay, and so we're solving for y. We'll subtract 4x from both sides here. I get 3y is greater than or equal to -4x plus 9. And then divide by 3. I get y is greater than or equal to -4/3 x plus 3. My y-intercept is 3. 1, 2, 3. My slope is -4/3. Goes down 4. 1, 2, 3. Goes down 1, 2, 3, 4 over 1, 2, 3. Okay, I could go up 1, 2, 3, 4, and over 1, 2, 3. All right. My line should be solid because it's or equal to. and then it's greater than, so I'm going to shade above. So everything above. And then also know that because it's a solid line, my line also could be a solution. And so choosing a solution here, I'm going to say 606. Oh, sorry. Is 3, -1? 1, 2, 3, -1. Yes, it is. Okay, it's on the line, but it's a solid line, so it works. Number 4, doing the same thing. I'll use red here. I'm going to solve for y, so I'm subtracting 4x from both sides. I get -6y is greater than -4x plus 24. Divide by -6. And so I get y. And notice what I just did. I had to divide an inequality by a negative number. So that means I need to flip my sign, right? Don't forget that. 2/3 x minus 4. So y is less than 2/3 x minus 4. 1, 2, 3, 4. My intercept. Up 2 over 1, 2, 3. Up 2 over 1, 2, 3. Down 2 over 1, 2, 3. All right. Now bring my ruler out. That should be a dotted line, right? Because it's less than, not or equal to. All right. And because it's less than, I'm shading below the line. Below. I'm going to ask, is 60 a solution? The answer, no. Okay, and it's not because as we look, 60 is here on that dotted line. And it's a dotted line to tell us it's not a part of our solutions. All right, so there we go. That is graphing inequalities. See ya.